Oh, where did it go? Okay.
All right, you guys. So let's go through these, and as a reminder, your first half of your homework for Unit 4, the Part 1 Delta Math assignment is due on Monday. Remember, you also have your quiz on Monday as well that covers those topics. So let's look at our warm-up and simplify the following. So today we're going to kind of build off of this simplifying and kind of get into a little bit with what you might see here in that third problem. So anybody want to tell us what did the cube root of negative 24 x to the 7th y squared z to the 23rd simplify to? What did that simplify to? Anyone want to help us out? Tell us what we got. What you find, Morgan?
Negative 2x squared z to the 7th cube root 3xy squared z squared.
All right, how does that sound with everybody? Look okay? Look good? Questions with that one? All right, so remember with your cube root, you're kind of thinking about it's like division, right? Groups of 3. It's how we got those exponents outside of what was left over underneath our radical. Now notice here we have all of these exponents and then we're going to square all of it. So it might make our life a little easier if we simplify first and then square. So we're going to think I can't simplify 2 over 3, but what about if I have x squared over x to the negative 4? What would that simplify to? Now x squared over x to the negative 4. What do you think, Yona? Good job. It would be x to the 6, and it's positive 6 in the numerator. What about y to the negative 3rd over y? What would that simplify to? What do you think, Laura? Amazing. Good job. What about z to the 12th over z to the 14th? What would that simplify to? Good job. Z squared in the denominator. So now I square all of that. And I have to square every single term. So think about 2 squared, we know is 4. What about x to the 6 all squared? What would that become? X to the 6 all squared would be to the 12th. Good job. We are going to multiply. And then you'd have 9 y to the 8th, z to the 4th. And you know you've simplified all the ways. Think about your variable terms, right? I have x, y, and z. Nothing else to combine. 4 over 9 can't simplify. So the third one was probably like our trickiest, right? Everything is raised to this 2/3 power. But even though it's a fraction, I'm not going to get scared. We're going to deal with more fractions today. And we're going to remember our rules. When I have an exponent raised to an exponent, what is that operation? Exponent raised to another exponent, what do I do to help simplify? Great job. So I'm going to end up with, I'm going to just keep it as 8 to the 2/3 for now. It's going to now become x to what power? 6 times 2/3 is going to become, great. What about y to what power? Awesome. And then I would have z to the, awesome, 1, which is just z. So now that you're here, what's maybe something you're noticing about this problem? And it's something about this that tells me I got to keep going a little bit. There's a negative exponent. If I have a negative exponent, where do I need to move it? To the denominator. Yes. So that would become y to the 4/3 power. I'll have x to the 4th and z in the numerator. And let's talk about 8 to the 2/3 power. Does anybody know anything about what 8 to the 2/3 power like simplify to? Anything about that? Here in 6, 3, 4. What about if I have 8 to the 2/3 power? Does anybody know if I have it to my power as a fraction and the denominator's 3? Does anybody know what that's the same thing as? You're right, it is a cube root. So this is the same thing as the cube root of 8 to the second power. What do we know from here? What would 8 to the second power become? 64. Do I know the cube root of 64?
It's 4.
It is 4, so that's going to be equal to 4. And that is actually what we're doing today. We're going to simplify something like 8 to the 2/3 power just to be 4, kind of through that route we've taken here. So before we do that, what other questions might you guys have with our warm up, yeah, Laura?
You just took the here. Like,
Amazing. Good connection. That's what we're going to do. Anything else we're wondering about? All right, so let's build off of that idea we were just doing in that last warm-up problem. We're going to kind of rewrite radicals. So exactly what Laura just said, I'm going to rephrase it. Take that denominator and you're going to make it the root of whatever. So we're going to first start to rewrite these radicals with fraction exponents. So we're going to rewrite the radicals as fractional exponents, which you might see as rational exponents. So when you see rational is a fancy math word for what? Fraction. Good job. So this means write your answer as fraction exponents. So we'll just kind of work today just for right now. We're just going to rewrite, and then we're going to build off of what we did last time. So we're going to rewrite and keep simplifying. So let's start here. I have the square root of x. What would that be equivalent to? My base is x, so it'd be x to the what power? What is that equal to?
1/2.
How did you know it's 1/2, Morgan?
I don't know.
I love the honesty. It was a great guess. Let's talk about why this was a great guess. If I have a square root, what's the secret little number here that I don't write? 2, yes. So if I ever have a square root, I know my denominator is going to be 2. And inside here with my x, I have that exponent of 1. So that's why it's 1/2. Remember, it's your power over your root. It's equivalent. Same idea. I have all the power over a root. Because, right, if I have this as a 1 here, 1 times p is just p, so that's equivalent. Now let's look at if I have the cube root of a squared. What would that be equivalent to? Awesome. A to the 2/3 power. Good. Lastly, I have the 5th root of b all squared. What do we think that would be equivalent to? B to the
1/10.
What was that?
1/10.
Not quite. If I have a 5th root, I know the denominator should be 5. So what's the numerator? 2. So I heard 1, I heard 2. But remember, think about this right here is a 1. So this is equivalent to the 5th root of b to the 2nd. So kind of and how you could have thought about this from our warm-up, let's check back in with that. I had 8 to the, was it 2/3? Power, and we wrote that as the cube root of 8 squared, and then we simplified it from there. Another way you could have approached this, so I want you guys to start like kind of doing a little bit more like mental math game here, in the sense of like thinking about doing these stuff without a calculator, because that's going to be like Ivy level stuff, right? You would be expected to do this without a calculator. So if I have the cube root of 8 squared, we said, okay, let's do 8 squared and then cube root it. But if that's going to give me a crazy large number and that I don't know and that I have to take the cube root of, something else you could do instead would be to do, okay, I can do the cube root of just 8 and then square all of that. Because these two are equivalent. So the cube root of 8 would just end up being 2. And then what's 2 squared?
4.
4. Is that what we got over here too? Yeah. So kind of different ways to approach it. But they'll give you that same result in the end. All right, what other questions do you guys have? So let's go do the other way now this time. So now let's start with our rational exponents. And we are going to rewrite as a radical. So if I say as a radical, what symbol does that mean? You should have with your answer. Or like a square root, whatever type of root it means. So remember, if I say with my directions, write as a radical, that means a root. So we're going to go the opposite direction this time. So if I have x to the 1/3 power, let's first just start off with my root. I would have what type of root? Cube root, and then it'd be the cube root of what? Awesome. I have x to the 3/4 power. What would that be equivalent to? The 4th root of x cubed. All right, I have y to the negative 2/3 power. What's maybe something you're thinking about here? It's a negative exponent, so how might I rewrite it first? If I have a negative exponent, what would I want to do? Make it a fraction. Yeah, 1 over y to the 2/3. Now, let's rewrite that. So it'll be 1 over y to the 2/3 would become, how could I rewrite that as a radical? Good job. The cube root of y squared. All right, so now we're going to work on rewriting and then simplifying. So kind of thinking about combining the rewrite with what we did last time. So what questions do you guys have before we get there?
No.
All right, let's do it. So why don't you guys take a minute and jot down these two problems, then we'll check in and see what you're thinking. All right, let's look at our first problem. I have 16 to the 3/4 power. We want to rewrite in radical form. So if I see radical form, what does that look like?
A root.
A root. Good job. So let's think about 16 to the 3/4 power. That's what root? The 4th root. No, I just like 4th root. But, yeah. All right, so I have the 4th root, and then what do I have the 4th root of? Yes, so this is option 1, but let's say we're, where it's fun, we're doing it without a calculator. Do I really want to do 16 to the 3rd power without a calculator? And then try and take the 4th root of that? No, what might be another way I could rewrite this instead? Where my numbers would be, I'm working with a little smaller, a little easier.
Do 4th root of 16.
The 4th root of 16, and then I would have to do what with all of that? Take it to the 3rd. Good. So these two are the same. This one, my numbers are going to be a little smaller, a little easier to work with, because what's the 4th root of 16? Great. So this is just saying, hey, this is 2 to the 3rd power, which we know is equal to, yeah. our second problem, we have 8x to the 15th all raised to the 1/3 power. What are you guys thinking about with this problem? If we have the 1/3 power, what symbol does that mean? Cube root. And does everybody see how I have parentheses around this? So all of this is taken to the cube root, which means I'm going to have 8x to the 15th all inside. Remember, if there's another number besides like 1 here, I could then, make that my exponent all the way out there, or make it the exponent underneath, either or. So now let's simplify this. What would the cube root of 8x to the 15th be equal to? Good job. 2x to the 5th. Alright. What other questions do you guys have here? Are you guys ready to try a couple on your own? Let's do it. Why don't you guys take a couple minutes, try these two on your own problems. Alright, what do you guys think? If you rewrote the first problem like this, could I simplify the cube root of negative 2a? Simplify all of that? No. You're not responding. That's good. That means no. So, the cube root of negative 2a, right? We couldn't simplify that. So, this option really wouldn't have helped you get any further. But this option would, because now I would have negative 2a to the 4th power. And what would negative 2a to the 4th power become? Yeah, 16a to the 4th. Now that you're here, can you keep simplifying this? Yeah, what would the cube root of 16 simplify to? Yeah, 2, and then inside of 2. What about if I have a to the 4th? What would that simplify? A outside, and what's left inside? Another a. There you go.
Brave and shepherd.
Thank you. All right, what about if we have 9x to the 4th raised to the 3/2 power? How might we think about that? Anybody want to tell us maybe how you rewrote it at first? Think about if I have a denominator of 2, that means what radical? A square root. And if I have 9x to the 4th, you could have rewritten it as like a couple different ways, right? I could have 9x to the 4th all cubed like this. Or you could rewrite it as a square root of 9x to the 4th and then cube all of that. Does anyone have a preference on like which one seems a little easier? The second one, right? Because what's the square root of 9x to the 4th?
3x.
3x. And now 3x squared. And now all I have to do is cube all of that, which would become 27x to the 6. And would you have still gotten that solution if you did it this way? Yeah, you just would have to like not do 9 cubed and then take the square root of that. Things might have gotten a little larger. Alright, what other questions do you guys have here? So we're going to do this, but just go the opposite way now in the sense of we're going to now start with our radicals and rewrite with rational exponents. So if I see rational exponents, what does that mean my answer needs to look like? Fraction exponents. So why don't you guys take a minute, jot these two down, and then we'll go through them.
I guess the word math should be like a quadratic progression. It should be a plus. Yeah, no, it should be like added and bracket. To the power of fractions added. But not with like common denominators.
Alright, looking at our first problem, we have the 6th root of 8x all squared. So if I want to write these as fractional exponents, how could I do that? What would my base be first? You know, always what's your base first? Base means like what are you taking the exponent of? Right?
2 to 6. 8.
8x is our base. And 8x, notice you have parentheses around it, is being taken to the what power? We have 2 over 6, and now that you're here, do you guys see anything? Right, this is the same thing as 8x all to the 1/3 power. And having the 1/3 power is the same thing as what symbol? A cube root, but do I want to write my answer as a radical?
No.
No, I want those fractional exponents. So, what you might start to do, if you are someone who's already knows, okay, this is a cube root, and what do we already know? 8, the cube root of 8 is just what value? 2. So you know this is going to be 2x to the what power? Now my x will just be 1/3. If you need an extra step to get there, you know 8 is the same thing as 2 cubed, and all of that's to the 1/3 power. So doing this process here might help you when your numbers get a little larger. So this, I know 3 times the third just becomes 1. Another way how we know we'll just end up with 2x to the 1/3. Okay, next up we have the 4th root of 192 x to the 6y squared. So, if I could, I would keep simplifying 192 in the sense of, like, if it was like a perfect, like, cube of something. Does everybody know what I mean by that? In the sense of, like, if I could break it down to be like 2 to some power, or 3 to some power, or 4 to some power. But unfortunately, 192, we can't. So that means this problem's a little easier for us. In the sense of, now, if I want to rewrite this as a rational exponent, it would just be 192 to the what power? Well, what's secretly this exponent of 192? 1, and then my base, the denominator would be 4. What about with x? I would have x to what power? So the what over what? 6 over 4. Can I simplify 6 over 4?
3 over 2.
Great job. Then I'll have y to the, how we get 1/2? Great job. So that problem gets a little easier just because I can't do anything with this 192. But like if you could, in the sense of if you had, here's a good example here. If I had the 4th root of 32 and I needed to write this as a rational exponent, how else might I rewrite 32? What number to what power? What do I know about 32? It would be what number to what power? All right, 16 is what to what power? 2 to what power? 2 to the 4th, which means 32 would be 2 to the, yes. So think about, I could rewrite that as 2 to the 5/4 power. So if I could break a number down at all, that's what I would do. But we just got, I would say you guys just got lucky here in the sense of 192, we can't like break it down anymore. All right, what questions do you guys have here? Are you ready to go the opposite or try some on your own? Where are you already on there? We're cruising. These are our last problems we're going to do. Alright guys, let's go over these, see what you were thinking. Alright, with our first question, we are writing as rational exponents, which means you want your answer to have those fractional exponents. So thinking about everything here, I have 125 x to the 4th y squared z to the 12th, and that would all be raised to what power? It's a cube root. Cube root would be what power? What was that? 1/3, yeah. Alright, so now thinking about here, if you're going through, maybe you do know what 125, the cube root of that's equal to. If not, you know you could also think about rewriting 105 as what to the what power. 125 is the same thing as what number to what power? 5 to the third. Great job. So now from here, you're just raising your exponent to your exponent, which means you're doing what operation between the two? Exponent to exponent means you're multiplying. So this will become 5x to the what power? 4/3, y to the 2/3, and then lastly z to the what power? Great job. And I have all of my fractional exponents. Think about all my answers with my exponents, so that's good right there. All right, let's look at our second problem here. Rewriting as fractional exponents. So maybe let's start there. So the square root of x would be x to what power? 1/2. And x to the fourth root of x to the fifth would be x to the whatever what. Awesome. So now that you're here, you could have done this a different way, but so it's just kind of note, maybe you did it a different way. I saw some people like seventh rooting everything. I kind of think about just kind of going through and like simplifying inside your parentheses might make things a little easier. Because if I'm multiplying here, what am I doing with my exponents? Adding them. And can I add 1/2 and 5/4 right now? No, because they don't have what? Awesome. So think about it. If I have 1/2 plus 5/4, how do I make that into a common denominator? Yes, so this will become 2/4, which means this is now x to the 7/4. And now that's all to the 7th power. And same thing, exponent raised to another exponent means we're going to multiply. So this will be x to the 49/4th power. What other questions do you guys have here? All right, so guess what? I have for everybody. So we're going to get started on our classwork assignment. And guess what? Out of your classwork